Hey folks, since we have done lot of data exploration, lot of data analysis, lot of featureization, including some basic featureization, some advanced featureization that includes lot of business acumen. So let's go slightly ahead and try to perform the machine learning algorithm on top of data. Again, in the previous session, what we have done is we have prepared our entire data. If I will talk with respect to our NLP session, we have prepared our entire data so that at the end we are able to apply the machine learning algorithm on top of data just to predict whether if we have question 1 and question 2, we have to predict whether they are similar or not, whether they are similar or whether they are not similar. That's the main goal behind what we are going till now. So we have over here, we have 10k data points and we have 220 features. Again, these are especially my featureized feature because initially we have our question ID 1, we have our question ID 2, and we have our Q1 which is my question 1, we have our Q2 which is my question 2, and we have our output feature which is all about whether this question is similar or not. That is exactly our very initial data, or often known as raw data. That was exactly our raw data. So on top of this data, what we have done is we have performed some basic featureization just to come up with some set of feature, including we have performed some advanced featureization. Then considering this Q1 and Q2, we have performed on top of something known as natural language processing algorithm, often known as word to vec or TF-IDF weighted word to vec. So this NLP section alone gave us approx 192 feature, which are exactly my vector representation of data. In addition to that, this section gives us approx 27 feature. So 27 features from this, 192 from this, plus 1 will exactly my output feature. This is exactly my output feature that we have to predict. So it means this is our entire data, and in this session we have to just apply the machine learning algorithm on top of these 220 features that we have. So 219 features will be my independent feature, which is nothing but this basic featureization plus advanced featureization along with some vector representation, plus 1 feature which is my output feature, which is all about nothing but a binary feature. If it is 1, it means questions are similar. If it is 0, it means questions are not similar. This is what we have to predict, because in the future, if we will get some new data, so considering the model that we have built, we have to just pass this new data to my model and we are able to predict this. So first and foremost, let's try to rename the notebook. So I will say, let's say a dot machine learning, whatever else, it's all up to you. Let's rename it. So let's try to import our pandas module. I will say import pandas SPTs because we have to read data. As we have to read data, your pandas will be got over there. Now from this pandas module, what I will do is I will say, hey, can I import a function? Can I import a function often known as read_CSV? You can just press tab, or you can do this in a manual fashion as well. It's all up to you. Cool. This is the function that you have. Cool. Now what I will do is I will say, hey, just execute this line of code. Using this read_CSV function, you have to read the file. Now here, very first we have to mention what exactly is my file path, which is all about this. So I will say my file path is all about this. My file name is all about final_features.csv. Cool. And let's append the R, which is all about rusting. That helps Python, or that helps this pandas module just to read file very efficiently. Cool. It will return a data frame object. Let's try to store it in, let's say, data. Sounds good. Let's execute this line of code. And if I'm going to say data.head of, let's say 3, let's execute this line of code. Now you will see this is the vector representation. Along with that, we have some featureized feature. Now what I will do is I will say, hey, can I call a columns property on top of this? The moment I will execute, you will see you will end up getting all these features that you have with respect to your core data set. Now first and foremost, from all these 220 feature, as we know, we have 219 feature which are exactly my independent feature, because this is that feature that we have to pass to our machine learning algorithm so that my model is able to learn some relationship. So whatever model will predict, that is exactly my output. That is exactly my output, or you can say that is exactly your target. So it means initially I have 220 features. I have to split this into two. This 291 is exactly your independent feature, and the one is exactly your dependent feature. This is exactly dependent feature because this is your output feature that is entirely dependent upon this independent feature. Hence it is named as dependent feature. So let's try to pick, or let's try to consider these 219 features as your independent feature, and the one feature which is all about a dependent feature which holds the binary value. Let's try to consider all this data. So what I will do is I will say, hey, we have a feature which is all about is underscore duplicate. So I will say data of, if I will press tab over there, this is exactly that feature which is exactly my target feature which we have to predict. So let's try to store this in, let's say, y underscore true. Let me execute this line of code. Now what I will do, if I will say data.drop, and if I will mention, hey, I need all data but I do not need this feature. So in such case I can think of calling this drop function. It means, hey, just drop this feature but do not update your data frame. So I will say x is equals to 1 because we have to drop in a vertical way. Cool. Let me execute this line of code. The moment I will execute, you will see you have 219 features or 219 columns. These are exactly your independent data that you have to feed to your machine learning model. Sounds good. Let's store it in x variable, or let's store it in x. If I will say x.shape, you will see you have 219 features. If I will say y.shape, you will see over here you have, oh my bad, it is y underscore true. Sounds good. You will see you have 10,000 total data points or 10,000 total entries over here. Now what you need to do is, as you will figure out, you have total 10k data points. You have total 10k data points. Now just to train your machine learning model, you need some training data. And just to evaluate how well your model is performing, you need some test data. So what we will do is we will say, hey, total data is 10k data points. Hey, can you split this data? Let's say in ratio of 70:30 or 7:3. Hey, can you split it? It means 7k data points will goes for the training stuff, whereas 3k data point will goes for the testing stuff. Hey, can you do this? Again, there are a lot of ways just to split this data. One of the handy way you can think of something known as train test split of your scikit-learn module. This is one of the extremely used way just to split data in something known as in training and testing. So let's try to do it. So if I will say from scikit-learn dot model underscore selection, you can just press tab over there. This is exactly your submodel. So this is exactly submodule. So I will say from this, hey, can you import something known as train underscore test underscore split? Let's execute and let's try to initialize this. So the moment I will press shift plus tab, it says, hey, you have to just pass all the parameters. Again, these are custom parameters that you can think of. So let me go through into its entire documentation. Let me show that. It says, hey, this is a class or this is a function. I have to pass just some array, some x, some y, some test size, and this is the optional parameter which is all about random state. It typically returns some x train, x test, y train, and y test. This is typically the hierarchy that my train underscore test underscore split follows. So I will say this is a hierarchy because we have to maintain the hierarchy. So I will say, cool, my x is this, my y is all about my y underscore true because I have restored all the dependent stuff in my y underscore true. Cool. Then you can say as, let's say my testing size is all about 0.3 because 0.3 is all about 30%. And just to maintain or just to provide the balancing in your dependent feature, you can think of something known as stratify parameter. So I will say stratify, let's say, is equals to nothing but my y true because you have to make sure that the output feature must be in a balanced way. Sounds cool. Let's execute this line of code. And if I will say x underscore train dot shape, you will see it has 7k data points. If I will say, hey, what is the dimension of x underscore test? Let's execute this line of code. You will see you have 3k data points. Now let's try to use something known as logistic regression. As we have a classification use case, hence you can think of something known as classification algorithm. So what I will do is I will say, hey, First and foremost, I have to import my logistic regression. So I will say from scikit-learn.model selection, you have to import something known as logistic regression. Again, if I'm not wrong, it is, I think, inside something known as linear_model. Cool. From this, I have to import this logistic regression. Sounds good. Let's initialize this logistic regression, and let's try to store its object. Let's say in LR. Now using this LR, I have to call this fit, and I will say, hey, just learn some relationship from your training data. So I have to pass my training data. So I will say my training data is all about x_train, and I need to pass some dependent feature as well, which is all about y_train. Let's execute this line of code. It will just take a couple of seconds, and this is exactly the logistic regression model. Again, these are just some warnings. If you want to get rid of, you can play with your filter warnings or with your warnings module. That's not a rocket science. Now using this LR, I will say, hey, can I predict on top of our testing data, just to evaluate how well my model is performing. So I have to just pass here x_test. Cool. Let me store whatever prediction it will return. Let me store it in, let's say, pred array. Let's execute. And if I will print this pred array, these are all the predictions that I will end up getting. Now let's try to evaluate how well the model is performing. So I will say from scikit-learn.matrix module, you have to import something else which is all about accuracy_score. Just to evaluate how well the model is performing, you can think of something known as accuracy score. Here you have to pass all the predictions and all the true values, which is all about inside your y_test. Sounds good. Let's execute. Now you will end up getting accuracy probably close to 72%. And just to get your confusion metric, what you can do is you can import something known as confusion metric. Sounds good. Inside this confusion metric, what I will do is I will say, hey, just pass some stuff, which is all about nothing but y_test and whatever prediction we have, which is all about pred. Sounds good. Let's execute. This is what you will end up getting. Again, in accuracy score, we have to pass just these two arrays because these are exactly my true values. You will say these are exactly my true values of my testing data set, and these are exactly my predicted values on top of my test data set, or you can say of test data set by some model M1. So just to evaluate how well this M1 is performing, you can think of something known as accuracy score. Similarly, this is a confusion metric. Again, as it is a binary feature, 1, 0, 1 means they are similar, 0 means they are not similar. As we have two subcategories, hence the matrix size is all about 2 × 2. So these are exactly my right predictions. You can say these are cases where my model is performing right. Similarly, these are something known as error of my model, which is nothing but 471 and 343. So that's how exactly logistic regression works. Again, for those of you who do not know what exactly logistic regression is all about, kindly check out the videos where I have explained all the stuff, all the underlying mathematics regarding this logistic regression. Kindly check out those videos. So that's all about this session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.